Welcome to Multiple Choice Question 13 of the 2006 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now just before we move on, I'd like to point out that the use of a CAS calculator is not appropriate for this question, but of course you can consult your notes when you do a problem like this. So for question 13, we're introduced to a transformation T, which goes from R2 to R2, which is just saying one Cartesian plane to another Cartesian plane, so that's not really that relevant, but you'll see that presented in VCAA questions like this. And the transformation maps the curve with the equation y equals log e of x to the curve with the equation y equals log e of 2x minus 4 plus 3. And the transformation T is one of the following options, and we've got to work out which one it is. Now, some of you may be able to inspect this quite quickly and work out which matrix it is, but you'll notice from the examiner's report in a minute that sometimes that actually led to students selecting the wrong answer if they didn't know how to deal with this properly. So there is a robust method that I like to use called reverse mapping, or something that I like to call reverse mapping. And the starting point is to say that y equals log e of x, our starting graph, is being mapped to y equals log e of 2x minus 4 plus 3. And what I'm going to do here is I'm going to reintroduce dashes onto the y and x term on the graph that we're transforming to. So we're going to have y dash and x dash on the right hand side as I've set it up. The next step won't actually change the left-hand side. We'll still just have y equals log e of x has become. But what we're going to do is we're going to take this 3, and in theory anything else that we could remove from the right-hand side, and move it over to the left-hand side to get it on top of that y, or next to that y. So the y dash term, we can subtract 3 from it, and that's about all we can move easily onto the y. So the other part of this will be equals log e of 2x dash minus 4, and we can't really rearrange any more. But what we can say is that this y is in the same position to the y dash take 3. So we can say, therefore, y is equal to y dash minus 3. And in a similar way, we can take this x that's inside the brackets and see that it's the same position as the 2x dash minus 4 over here that's inside those brackets. So therefore we're saying that x has become, or is equal to, 2x dash minus 4. And now what we need to do is we need to rearrange these two smaller equations involving just y's and just x's for the dash terms. So for the first one, we can just add 3 and we'd get y dash by itself is equal to y plus 3. And for our second equation, we can add 4 and then divide 2. So that will give us x dash by itself is equal to, and thinking back to what I just said, we were going to take x and add 4 to it, and then divide it by 2. And another way of thinking about that is x over 2 plus 2. So that's just splitting apart that fraction, which is actually going to help us when we get to finding which matrix is going to result in that transformation. So looking at what we've got, we need 3 to be added to y. So if we look down the 5 options, the 3 being added to the y is going to happen in the matrix that's added on at the end. So there's a plus 3 here, plus 3 here, plus 3 here, plus 3 here, and a plus 3 there. So none of those has managed to eliminate any of the options, but it's good to know that all of them result in that translation of 3 units in the positive y direction. So the difference must be the 2, which sometimes is presented as a 4 or a negative 4 in that same matrix at the end of the equation. We can identify that we actually want a plus 2 in that position. So even though we have 2x minus 4 in the rule, we actually need a plus 2 in the matrix system. So that 2 is correct, and that's the only one that's actually correct. So A must be the correct answer. And it's useful to see that the 0.5 that you can see just here, if I just put a little aqua tick next to that, that does need to be there, because another way we could have written this is equal to 0.5x plus 2. So we need x to be multiplied by 0.5, which A does that for us as well. So that all checks out, and that makes A the correct answer for this question. From the examiner's report, we can see that this was an exceptionally challenging question, with only 33% of students getting the correct answer for this problem. And option B was a common distractor, where they didn't sufficiently, or the students that chose that option didn't sufficiently deal with the 2x take 4 inside the log. So one thing that the examiner goes on to say is that students needed to do some rearranging if they wanted to inspect this directly. So if I just rewrite out, similar to like we had before, y equals log e of x needs to map to y equals, and it was log e of 2x subtract 4, which I can actually factor out the 2 and just have x minus 2 in a bracket there, and then we still had a plus 3 at the end. And from here we can see the transformations that occurred more clearly. So for example, this 2 here is actually a dilation by a factor of a half from the y-axis. The x subtract 2 just here is a translation of 2 units in the positive x direction. And the plus 3, as we discussed on the previous slide, was the translation of 3 units in the positive y direction. And just to summarize all of that, it's the 0.5 in this position of the matrix that multiplies x and causes the dilation by a factor of a half from the y-axis. The 2 in this position is added to x, causing that translation of 2 units in the positive x direction. And finally, the 3 here is responsible for that translation of 3 units in the positive y direction that we spoke about. And the term, or the number that didn't change, this one here, if you change that number, that would be responsible for a dilation from the x-axis. But obviously that didn't occur here, so we just leave a 1 there in that matrix setup.